Hey, I'm Greg. I work for Hotels.com, another Expedia brand. Sorry, I've already messed up. I'm like 1 second in. Okay, so I used to work for Hotels.com until a couple of months ago. So if you want to ask me about Hotels.com or HomeAway, feel free to grab me as well. But today we're going to talk about effect types. So what is an effect type? If you use Slick for database access, you might have already used an effect type. So in Slick, you use dbio action, and basically this is an effect type for working with database operations. And it's kind of interesting that they use that rather than just Future everywhere. I'm hoping people have used Future, by the way. Has anyone not familiar with Future? Okay, Povolas. I worked with Povolas, so thanks for trolling. Yeah, so there are a bunch of different kind of effect types out there, but we're going to focus on general purpose effect types. So they exist to encapsulate any side effect in code you have, and that's really general. And a bunch of these have popped up in the Scala community in the last few years. So there's Cats Effect IO, Scalaz ZIO, Monix Task, and we're going to take a look at these three, and I'm going to try and justify why you should use effect types, why you shouldn't just use Future, and compare and contrast these a little bit. So yeah, first we kind of need to talk about Future. I basically want to convince you that Future isn't good for working with side effects full code. And that's kind of weird because I actually quite like features. Coming to Scala from Java, I was used to working with threads and doing locking and stuff like this, and that's pretty horrible. And with features, you can compose concurrent asynchronous code quite nicely. You can just use it in a for comprehension. Unfortunately, features, I would say, are not very good for working with side effects. So yeah, they're good for async concurrent code, bad for side effects. And for those that don't know, so Future is eager. So when you create a Future, it starts executing straight away, and it's also memoized. So when the Future finishes, that keeps that result around, and you can access it multiple times. And yeah, you can compose it nicely with a for comprehension. However, I would say you can't compose it that nicely if you're doing side effects. So this is an important point, which is easy to gloss over, and I know I did for a while. So if you create a Future, and inside that Future, you perform a side effect, just by creating that Future, you're performing a side effect. So when you create a Future, it schedules it in an execution context, and pretty much as soon as possible, it's going to start running. So you're starting that side effect, you're kicking this side effect off. And I think, yeah, why does that matter? Do we care? Okay, let's take a step back. So why are side effects bad? I mean, shout out, anyone? Why don't we like side effects? Don't compose, yeah. Why don't they compose? All right. Yeah.
You cannot use a substitution model.
Say again, sorry?
You cannot use a substitution model.
You can't use a substitution model, so they're not referentially transparent. So if you have, yeah, exactly. So to take an example, if the type doesn't tell me anything as well. So if just with side effects, if I have a function which returns unit, I don't know what it does. I have to go and look at the code, and almost certainly it relies on the state in my system being in a certain way so that I can execute this function that returns unit. And side effects aren't good, and whenever you create a Future, you're performing side effects. So let's take a look at Futures. So here I've just got a for comprehension, and I'm uploading documents, and this returns a Future of unit, so presumably it does some side effect. And we said that monads compose nicely inside for comprehensions. So when you use a Future in a for comprehension, you get this sequential ordering of operations. And this works okay. However, once you start substituting things out, right? Once you start extracting a variable, eventual A, so if I run this now, and I've just got this object that will run it 10 times, then you can see that it's going to be non-deterministic in order. So sometimes A goes first, sometimes B goes first, because with futures, when you extract them like this, you're creating them earlier. You're starting them at the same time. You can't just substitute them whenever you want, because they're not referentially transparent, because they're performing side effects straight away when you start them. And this is actually really useful. Like, I use this all the time because I want to run my futures in parallel. But I think this makes it hard to reason about. I think that, I literally just, if I extract variable, it changes the performance of my program. If these effects relied on each other, it wouldn't work. And if I put this in like a service, I have to be careful about when do I actually call the future. So you kind of don't realize it because you're doing it all the time, but like you have to be really careful when you start a future, and it would be nice not to. So futures are good, side effects are necessary. Futures are bad for doing side effects. We need to do side effects. We want to be able to do them concurrently and asynchronously. I just think that effect types are a better way of doing that. So let's start with Monix. So has anyone heard of Monix? Anyone used Monix? Okay, cool. So Monix is a library for asynchronous programming in Scala. And that sounds very general because it's quite general, and it's actually an umbrella of a few projects. But we're just going to focus on Monix eval. So Monix eval provides task, and this is an effect type. And it's quite similar to future, really. You can compose tasks in full comprehensions. And also, like future, when you have this idea of like the failure case, and that's an exception. So, yeah. Unlike future, though, a task isn't eager, so it's lazy. It's lazily evaluated. You have to explicitly run it. And also, it's not memoized. So if you run a task twice, it will actually run twice. So let's take a look at a Monix task. So this is the same thing. Looks pretty similar. So now my upload function I'm using returns a task of unit, and I can still compose this together in a full comprehension. Now I have to say run to future. But the difference is that like if I extract these, the task is referentially transparent, which means I can freely substitute, pull things out, refactor, not worry about when do I call the service to get my task. I don't have to worry about that sort of stuff anymore. And if I ran this again and again, it would always do the same thing. So this, I believe, makes it easier to reason about your code and easier to refactor and stuff like this. But we've lost something already. So parallelism, I just showed you with futures, if you pull these variables out, they run in parallel. Well, what do I do with Monix, right? So let's take a look at that. So you can't do it inside a full comprehension, basically. So what you can do is you can say task, so we're using Monix task, and there's different operations we have for this. So we have parsit2 is one of them. This is more awkward, like for sure, but the idea is like you're explicit about this, and it's clear when you're doing it. So this way you could actually run them concurrently. And you can also, if people have used future.sequence, when you create a lot of futures and sequence them, you'll run it in parallel. With Monix, sequence wouldn't run things in parallel. So if I run this, it would run one at a time. Sorry. This will run one at a time because that's by default, that's what it would do. So with Monix, you've got to be explicit and you've got to use different methods. So in this case, we can use gather. And gather will actually run everything in parallel. So you can still run things in parallel, just you have to be more explicit about it. And the other thing as well is what about execution context? So with future, every time you map over it or you flat map over it, you need an execution context. So in Monix, 'cause at the end of the day, like each time you're running a future, it needs to run on a thread. And with Monix, you have a scheduler. So let's take a look at scheduler. So if we go back to this example. So here, so I said that when we create a task, nothing happens. And it's only when I do, in this case, run to future, that we actually, here it's going to run against a scheduler and give us back a future, a cancelable future in this case. So, yeah, so this is already quite nice because it means you don't need the implicit tax of having an execution context everywhere inside your app. A lot of the time when you create a feature or a task, if you're just doing CPU-bound operations, you don't really care where it runs, but you always have to provide that execution context. And here, because it's lazy, you don't have to worry about that. The other thing as well that I should cover is sometimes this isn't good enough. So here I could give it like a scheduler, like the global execution context. I can create a scheduler from that. But sometimes I might have blocking IO operations, and I actually need to say, yeah, this task I want to do on a separate thread pool because it's going to block a thread. And so for that, you still have the ability to do that. You can say execute on, and you can give that a scheduler. And you can create schedulers from an existing execution context you might have. They also have like convenience methods for like creating an IO execution context scheduler. Scheduler actually does extend execution context. So you can do this. You can actually the certain pieces that you know that are doing blocking IO, those you can make run on a separate thread pool. But everything else, like you don't worry about it. You just let the caller do that. Okay. So, yeah, so far I've kind of been focusing on it's easier to reason about, you can refactor your code, but there are other benefits as well, even if you don't buy into that. So, performance. So with a feature, every time you perform a map operation or a flat map, you have to give the execution context, and you're introducing an asynchronous boundary. So every time you're scheduling another piece of work to run on your thread pool, and so you're finishing your operation, and then you're saying map and schedule this, and there's like this delay between it finishing, submitting it to the thread pool, and it being executed. And in all of the effect types we're looking at today, that's not the case. There's no need when you map to actually force an asynchronous boundary. So because it's lazy, what you can do is you can take, if you've got 3 map operations, you can compose the functions inside the 3 map operations into one and just run it straight away as soon as the task finishes. So yeah, you actually get a lot better performance with any of these effect types. And that's a pretty good reason. Another one is resource safety. So all of these effect types that we're going to look at have the idea of a bracket. So a bracket is kind of like the finally block of a try-catch. So you can have your task and say, like, once that's run this, right? So release this resource. And if you use like FS2 with Cat's effect, this is used there to give you resource safety. Also, another point as well, like with Monix, for example, there's a lot of convenience functions we get. So here, the one thing that's really useful, would be really useful when I worked at hotels.com is timeout. So when I worked here, we had a web service where, we just fetch a couple of data models from Cassandra, and then we merge them and transform them a number of times to generate our response object. And because we didn't want to slow down the customer experience, we introduced like circuit breaking or timeouts. So we just timed out after 100 milliseconds. And with future, there's actually no way of stopping a feature. Once you've started the feature, you can't stop it. So timing out a feature, you can't really do. But with Monix, you can actually time things out. So if I introduce a timeout here, and I say timeout after 100 milliseconds, then, before I turn it into future, then this will actually time out. So if I was to try and do something like this with future, I would get a timeout exception, but I would also continue to run the operations in the background. And if I did 600 milliseconds, then you see the first one will run, and the second one, we have a timeout. So you actually can really time out things with effect types. Okay. So that's Monix. Let's have a look at Cat's effect IO. So yeah, this is another effect type. This one under the Cat's ecosystem. And to be honest, it's quite similar to Monix. So yeah, it's lazy, it's not memoized. It's not surprising that it's quite similar because the author of Monix is also the main contributor to Cat's effect. But that said, there are some differences. So the differences basically are that Cat's is more principled. So Monix has a lot of convenience operations. I didn't mention, but with Monix you can actually say this task is memoized. You can say memoized, and then it will remember the result, like a future. And that's something that breaks referential transparency. And so Cat's doesn't provide that by default. So, and Monix also has really good interrupt, like to and from future. And yeah, Cat's is just a bit more principled and doesn't provide lots of these convenience functions. Otherwise, it's quite similar. So let's have a look at that. So it's pretty much exactly the same. I've got an IO of unit instead of a task. These are referentially transparent. I could freely move these out and refactor. And now I call unsafe to future instead of run to future or whatever it was. And yeah, it's pretty much the same. One difference is that Monix, with Monix, we took a scheduler when we actually evaluate this task. So we're actually running it on a thread pool. And then the code will return immediately and you get a future which will finish later. With Cat's IO, when I run this, there's no asynchronous code in here. It's all synchronous IO. And so this will actually just run on the current thread. But yeah, to be honest, it's pretty much the same. And yeah, so let's take a quick look at Scalaz ZIO. So once again, it's quite similar. To be honest, I've not looked into this one as much, but it's definitely lazy and not memoized. So you still have referential transparency, and it's easy to reason about. The main difference is that with ZIO's IO monad is a bifunctor. So a functor is anything which has a map operation. So like if you use list, option, you can map over it. Bifunctor is anything where you have map and left map. So you have this idea of like a success and a failure case. So like in the standard library, you've got either. So you might like have an error type with your either and you can modify that. So with ZIO, if I create one from like a pure value, then there's no way an error can happen. So the error type is nothing. And this is different to Monix task and Cat's effect IO, whereby they kind of take the stance that exceptions are unavoidable on JVM. So they make you use throwable as your error type. But with the ZIO, you can actually change that. Yeah. We can take a quick look at the same code example in Scalaz ZIO. This one, I would say, is even more principled than Cat's effect IO because I struggled to get an example where I could just run it to a feature, so I had to implement this Scalaz ZIO app trait, and yeah, but essentially same thing. The main point is just that this is easier to reason about, and things like timeouts are actually doable for any of these effect types. Yeah. Okay, so that's ZIO. So it talks about Cat's effect IO. Cat's effect is actually like a broader thing. So it's got this specific effect type, IO, but it's also got a bunch of type classes for effect types. So just as a list might have a type class like the monad type class, so you can flat map over a list. You have functor, so you can map over a list. An effect type can have these type classes, bracket, sync, async. And here's a nice image that explains what they do. So like, and this is from this Twitter account, I recommend you follow it, lots of cats comics, basically. Yeah, so bracket is this thing which gives us this like finally block, the resource safety, all the way up to like concurrent effect, which basically can do anything. Yeah. So ZIO, cats, IO, and Monix task all implement these type classes. So this means there's like good interop between them. You could mix them if you wanted to. But importantly for us, it means that any library that's coded against Cat's effect, you can use any of these effect types. So if you use relation databases, Doobie, with Doobie, you can use any of these. If you use FS2 for streaming apps, you can use any of these. Or if you use Finch or HTTP4S, you can use any of these effect types. And it's kind of it's up to you. And yeah, to take this analogy of like comparing effect type to lists a bit further, just as if people have used Cat's non-empty list, this is a list where you guarantee it's not empty. So you can't ever do non-empty list.head. If you do list.head, you can get an exception. Cat's non-empty list like gives you safety and guarantees that won't happen. In return, it kind of makes it a bit more boilerplatey to create one and use them. And yeah, in that way, like Cat's IO and Scalaz ZIO are more restricted than task. It's a bit harder to do parallelism, stuff like this. And in another sense, ZIO is less restrictive because it doesn't restrict the error type. You can freely choose that. So let's take a quick look at the type class, Cat's effect type classes. So here I've implemented my upload function from earlier, and now you get to see the horrible implementation. It's just sleeping and then doing a print line. But I've coded this against the Cat's effect type classes. So it needs a timer because I'm going to sleep. But this is going to be like a non-blocking sleep. And I need the sync type class because I'm going to capture a synchronous effect. So print line is like synchronous. Yeah, but now this can return any effect type which implements these type classes I can use with this function. So to use it with cats, I just say, okay, run it with cats IO, and this will work. And same with Monix, I can just say run it with task, and same with like ZIO. So yeah, you can write your code against Cat's effect, and then you don't have to like choose one of these. You can work with any of these. You can also use it for interoperability, so you can turn any of these into any of the other ones. So if you want to create a ZIO IO from a Cat's one, you can do that, or from a Monix task. Yeah, and you can just do that for all of them. So I guess like disadvantages. Why not use it? There's more to learn. Like you've got to learn a bit more. I don't think it's that much. I think the main thing is like when you come to features, it's a completely different model to any other way you would do concurrency and stuff. Here it's quite similar. You're still composing it in the same way. Yeah, different API to learn, different methods to learn, but that's probably not a big deal. Also less widely adopted. So adoption is pretty good. If you use like the type level ecosystem, then this is quite wide adoption. But if you're using Play or Akka streams, it's going to be quite awkward, right? So but even then, it's not that bad. I would recommend you can implement your services against any of these effect types, and then just in your Play controller, you can say run to future, or in your Akka streams code, you could do map async and just run to future inside there. Okay. So yeah, in summary, side effects in futures are bad. They make it harder to reason about your code and compose your code and move things around. There's a number of good alternatives. Effect types, not only do they help with reasoning, they also give you better performance, real cancellation and timeouts, resource safety, and yeah, kind of my thoughts are Monix is like the easiest to move to coming from futures. It has really good interop with futures. Cats and ZIO are more principled, and so things like running stuff in parallel may be a bit harder, but that's kind of a trade-off, right? Like if it makes it more difficult, but it stops you from messing things up. It's like with non-empty lists. You can use a list, and then you just be careful that you never call head in case it's an empty list. So it's kind of the same here. Like Monix gives you more power as a user, but just be careful. Another thing was that using ZIO, one of the things that was really, the Scalaz ZIO, one of the things that seemed really appealing to me is the fact that it's a bifunctor. So you have control over the error type. So I don't know if people are using either T in cats. A few. So yeah, there's people that are using either T and futures. You probably have either T or future everywhere. And you probably wouldn't need to if you're using ZIO everywhere. So it's quite appealing to me. Unfortunately, if you want to use like Doobie or Finch or anything, that's coded against Cat's effect, and Cat's effect, it requires that the error type be throwable. So you can't take advantage of control over the error type if you're using any Cat's effect, if you're using it via the Cat's effect interface, so if you're using any of these libraries with ZIO, which is kind of annoying. Maybe that'll change in future. And then for me, so Monix is the most mature, it's the oldest, and the documentation is really good, and it's quite easy to move to from future. So for me, that's kind of my preference. Yeah, ZIO is interesting, but doesn't feel like the docs are not as mature, stuff like that. But yeah, so that's my takeaway is use Monix.